Okay, so we are moving on to part 3 of this lab demo of 9228. Part 3 is inter-area summary route configuration. So let's look at what those look like before I drop them in. Let's see. So on the one hand, we've got um, two Class C networks, 192.168.1.0, 192.168.2.0. Both of these are /24s. Um, and so we're not using 0. We're leaving 0 alone. We're not touching 3. The simplest way to do this is and the simplest way, honestly, to think about any kind of route summarization is to look at your routes. If they're contiguous, which is to say they are sequentially related to each other, say 192.168.1.1.0.2.0.3.0, etc. If they're contiguous, it's easy. If they're not contiguous, discontiguous, it makes it a little harder, but you still have to think in terms of the first one you need to allow for, the last one you need to allow for, and then you start thinking about your subnetting table. You know what? I'm going to put that up right quick. Okay, so here we go. This, if you will pardon the fact that I'm looking at this in Paint, this is a table with which you should be extremely familiar by this point. Now, granted, if you've learned a slightly different way of approaching this, the eternal headache that we call subnetting, you may have a slightly different view of this, but that's fine too. Notice you've got the 1.0 and the 2.0 network. So a mask, an interval of 2 wouldn't account for it. An interval of 8 is too big because we only need to essentially to cover 0, 1, 2, and 3. So that means I've got an interval of 4, but I've got it in the third octet, which is why this looks like this. Now, one of the things you have to pay really close, you have to compensate for here is that while your networks are stated in, your networks are stated with standard dotted decimal subnet masks. Your interfaces are built with dotted decimal subnet masks. Your network statements are built with inverse masks. Your range statements go back to using a standard mask. So what this does, this range 192.168.00.255.255.252.0, that's a network interval of 4, which allows me to, would also allow me to roll in a 3.0 network if I wanted to. Or even if I was being, say for example, I was scraping the bottom of the barrel and I needed to use the 1.0 network. And I had routers that were configured to allow that to happen. I could do this quite easily. So as you're looking at these route summarizations, think about inter-area route summarization specifically. Think about supernetting. It's subnetting, only backwards. Look at your networks, look at how they relate to each other, figure out where on the table you need to go and which octet you need to use to make this change. Now, if you're a little fuzzy on your subnetting, honestly, that is something you need to address. Chapter 1 in the book is all about subnetting. And as you've heard me say in class, if you learn this my way, great. If you start off my way and find a slightly different way of thinking about it, great. If you need to take everything all the ways that work for me and throw them out the window and learn your own way of doing this, that's fine too. Whether it's the magic number or the powers of 2 or whatever. Bottom line, you need to know subnetting cold, because it will show up on your tests, it will show up in your labs, it will show up implicitly time and time and time again in your certification exams. I would not have gotten through Sec Plus or CCENT or CCNA if I didn't have this cold. Now, you might not have to use it on any given test, on any given question, but the chances are that you will need it are very good. And even if you don't ever have to generate the subnetting table for that, for a certain test, the ability to be able to do so at will. And this is the kind of thing that frankly belongs at the top of your command reference. If you're taking a test, hands-on or written, and you're allowed for a networking class, and you're allowed to have a memory aid, shall we say, this belongs at the top of that. Whatever else you've learned, whatever command syntax you need to know, whatever alphabet soup you need to remember, this belongs at the top. So that if you do hit a question like that, you can work your way through it quickly. So let's actually talk about, now I'm going to implement this. So I'm going to go to router 1 OSPF. Now, the fun thing here is this isn't going to cause a reconvergence of the network. So say, for example, when I put in my MD5 authentication stuff, I broke the network. It had to restart, reconverge, boom. This isn't changing that. So I'm not going to break my neighbor relationships, but it is going to change how well, how much information these areas pass around between each other. With a little bitty network like this, you're really not gaining all that much, to be honest. But if you have a very large network, on the other hand, this can be quite useful. So, okay. I forgot the config T at the top. Silly me. And of course, if you're going to copy this, make sure there's an exclamation point at the top, because otherwise it will not know what part 3 means. So there's that. Now, notice that it is already reconverged. So what I did, I jumped from router 1 to router 3. Notice now here on router 3, I've got a new inter-area route, 192.168.0.0/22. This is the third octet equivalent of a /30, which you should be very familiar with from building your serial lines. Notice that we don't see 1.0 and 2.0 anymore. We see 0.0, and then you see its own 4.0, 5.0 networks. What we're going to do now, actually, let me make sure that there's nothing of this nature on router 2. Oh, okay. Now, okay, so we're going to actually crank this down again. And the thing to note here is we're not going to do any of this on router 3. We're going to do this on router 2, because router 2 is the area border router. Router 3 doesn't need to summarize anything because it's a strictly internal router. So on router 2, we are going to do this. Area range 00224.0. We're doing that to take in, let's see, 4.0, 5.0, 6.0. It even takes in, honestly, the 12 and the 23. Our 24.0, that's the equivalent, that's the class, that's the third octet equivalent of a /27 with an interval of 32. And we did that because our instructions for that, going all the way down here, are to let's see. Um, we're going to look at the LSTB, summary area routes. Calculate the summary route for the networks in Area 3. So thinking about that, the networks in Area 3 are 6, 12, 23, 4, and 5. So in order to get, I mean, if it was just 4, 5, and 6, we could do this with another /22 starting at 4. But we also have to accommodate 12 and 23. So we have to go all the way up. So obviously, with accommodating, if it was just 4 through 12, we could do this with a /21. Actually, no, not a /21. But yeah, we could do it with a /21 because no /20, an interval of 16. But with a 23 in the mix, we have to go all the way up to 32. And of course, there's nothing in the middle between 16 and 32. So eight's no good, though an 8 would have sufficed for 4, 5, and 6. 16 would have sufficed for 4, 5, 6, and 12. But for 4, 5, 6, 12, and 23, we need that network interval of 32. So this is what we're doing. And we're going to do it here on router 2. Bam. Now, what we're going to see here, honestly, let's actually look at that route, show IP route again. Now, notice that this show IP route doesn't happen. The information we give to router 2 doesn't propagate to router 3, but we will show it on router 1. See, router 1 knows about O.O/19. Remembering that the third octet starts at 16, so the equivalent, a third octet equivalent of /24 would be /19, or 16 plus 3. 3 bits borrowed. It's going back to that table. So we borrow 3 bits. We borrow the 128 bit. We borrow the 192 bit. We borrow the 224 bit for an interval of 32. The thing to note is this middle row could also be called your interval. Not the number of networks specifically, but your interval. In the 4th octet, that interval is literally the number of hosts you support. In the 2nd and 3rd octet, that interval indicates what you add to the network address you start with, going from, say, 192.168.0.0 all the way up to 192.168.32.0. So with this /19, we're representing the networks on the router 3 side of the network to router 1 as though there was a single network that contained 192.168.0.0 all the way through 192.168.31.0.255. So that's what this looks like. I hope this was helpful, and I will be putting up the next set of demos either later today or early tomorrow. I'll also be covering the lecture material for Chapter 9. You should, of course, read it in Netacad for yourself. It is really important to get the nuances of this, which I honestly can't cover. So read the chapter, do all the stuff you would normally do, and I'll talk to you later.